During this session, I'm going to provide the evidence which supports the existence of the ideas and concepts of general relativity. So, testing general relativity, we're trying to test to see if a great mass really causes the bending of space-time. And the bending of space-time would cause light rays, let's say for instance passing near the Sun, to be deflected by the curved space-time created by the Sun's mass. So this prediction was actually confirmed by astronomers during a total solar eclipse in 1919. What they did is Eddington stationed himself on an island off the western coast of Africa and sent another group of British scientists to Brazil. Their measurements of several stars showed that the light from these stars had indeed bent as it grazed the Sun by the exact amount of Einstein's predictions. Einstein, on this point, became a celebrity overnight. Okay. So what they were doing, if we look carefully, is that we have a star whose actual position is behind the Sun, so you shouldn't be able to see it, and yet you can see the Sun because the light is deflected. So this is a little bit like the impact of refraction when you're looking at fissures in the water and their location is actually different. In this case, the light is bending because of the mass of the Sun. Furthermore, this is, creates something which is often known as gravitational lensing. And gravitational lensing is a tool which allows us to see distant objects by the fact that there's natural bending because of a massive object. And what we end up seeing is a bright object which is directly behind a massive object. We'll see apparent images and which appear to be like a ring, and this is known as Einstein's ring. So the apparent images create a circle if we have a gravitational lensing situation. And gravitational lensing really does happen. If we look at this example, we can see examples of Einstein's rings in this diagram, and that's because of more massive objects in front of these distant galaxies, and therefore the effect can be clearly seen. Not only that, Newton's laws described perfectly the motion of all the planets except Mercury. Mercury kind of didn't work. There was an anomaly with Mercury's orbit that Newton's laws could not explain. And it had a precession. It kind of seemingly flipped around on itself, which was very difficult to understand. Nope. And by looking closely at Einstein's general relativity, this could be explained by the curvature of space, and Mercury's proximity to the Sun means that this becomes more exaggerated than any other planets. So there's some examples of how general relativity or evidence of general relativity can be observed.